next topic that we're going to discuss as we simplify radical expressions is what to do when you have the square root of variables with even powers. So we see here that this is 2n, and so when we multiply a number times 2, we end up with an even number. So this tells me that I have an even power. And it says here that the square root of x to the 2n power equals the absolute value of x to the n. Before we address the absolute value, let's just address what's going on here. Okay, so if I want to find the square root of a number in this form that is raised to an even power, the first thing I'm going to do is eliminate the radical sign. Next, I'm going to divide the exponent by 2. So if I had 2n and I divide it by 2, I'm going to end up with n. Okay, so I have this expression radical x to the 2n, so I got rid of the radical sign. And then I divided 2n by 2 to give me x to the n power. The last thing I have to do is take the absolute value of the result. Now, you have to think carefully about why this would be. First, let's just do an example to show how this works, and then talk about why you even need to use absolute value. Well, if you have something such as x, radical x to the 10th power, and you want the square root of that, I would eliminate the radical sign, okay, divide the exponent by 2. So here I have 10, 2n equals 10, and what I need to do is divide that by 2. So 2n divided by 2 equals 10 divided by 2, which equals 5. So n equals 5. So now I'm going to get x to the 5th power, and I need to take the absolute value of that result. The reason has to do with the definition of radical. As I mentioned, when we talk about radicals, when you see that radical symbol, it's telling you to take the positive or principal square root of the expression. However, if I don't use the absolute value, I could end up with a negative result. And here's how. If you have a variable, it's representing a number, but you don't know what number it's representing. So let's say that x represents -3. So let x equal -3. Okay, so let's say I have something like this. It's asking me for the square root of x squared. Well, really, what this is, whether I know it or not, is that x is standing in for -3. So let's take this. If I just go ahead and say, okay, I'm going to use the first 2 steps of this system. I'm going to eliminate the radical sign, and I'm going to divide the exponent by 2. Well, the exponent is 2. I simply divide that by 2 to get 1. Okay, so I got rid of the radical sign. That's going to give me -3, and my exponent is 1. Well, I now ended up with a negative number. That's why you need to add the absolute value. If I take the absolute value, I'm going to end up with a positive square root. So instead of, this is 9, and instead of saying, okay, I end up with a negative square root of that, I'm going to end up with ensure that positive square root by using the absolute value symbol. Now, there's one more aspect to remember of this. Let's say that I go through and I have some expression that I need to find the square root of, and it's to an even power, and I go ahead and find the square root, and it comes out to x to the 4th. Do I need to write the absolute value of that? At the end, it ends up being my expression, whatever was under here, ends up being x to the 4th. And I put my absolute value just as shown above. I actually don't have to do that. And the reason is, whatever x is, if it's raised to an even power here at the end, it's going to end up being positive. If x is -1, for example, let's look at that. X to the fourth is -1. You can end up with 1 times, and then -1, and then 1. Okay, it's going to end up being positive because it's multiplied out an even number of times. So x to the fourth is, even if x is negative, x to the fourth will always be positive. Whereas if I look at something like x to the third, if x, so here x was equal to -1, and if I have x to the fourth, it ended up positive. So I actually don't need to write the absolute value, because in this case the expression x to the fourth is positive. The absolute value is already given. Okay, if I have x to the third, that's an odd power. It's a different story. Because -1 times 1 is 1, times -1 would be -1. So x to the third equals -1. And remember, I don't want to end up with a negative power, with a negative expression when I'm dealing with the radical. Therefore, I do need the absolute value, because the absolute value of x to the third does not always equal just plain old x to the third. If x happened to be positive, then yes, x to the third would equal the absolute value of x to the third. But I don't know that, because this is a variable and I don't necessarily know what the variable represents. Therefore, when you use this system and you come up with your result, which may have multiple expressions, it might be the absolute value of x to the third times the absolute value of y to the fourth times z, the absolute value of z, you really only need the absolute value symbol around the part of the variables that are odd powers. And this will be illustrated in one of the examples. Okay, a second rule that we're going to use to simplify radicals is the quotient rule. The quotient rule tells us that the square root of a divided by b is equal to the square root of a divided by the square root of b. Taking an example to illustrate this, if I have 36x to the fourth divided by 16y squared, and this whole thing is under a radical, I can use the quotient property to rewrite this as the square root of 36x to the fourth divided by the square root of 16y squared. Now that I have this, I can see a way to go ahead and simplify. Using the product property, I'm going to look and see what I have, and do I have perfect squares? I do, and I actually don't even need to split them off because 36 is a perfect square. So I'm just going to go ahead and pull that 36 out, the square root of 36 out, and that is 6. And then I have x to the fourth. And remember what we just talked about with even powers. This is going to be x. 4 divided by 2 is 2. And I don't even need the absolute value bar here because this is already even. It's an x to an even power. So this expression x squared will always be positive. 16y squared, I'm going to go ahead and take the square root of that. That's 4. The square root of y squared, just divide 2, and then you end up with the absolute value of y. Okay, so again, you can use the quotient rule to simplify radicals just as we use the product property. Okay, in order for an expression to be in simplest form, in addition to having no perfect squares under the radical, there must be no radicals in the denominator. So the first criteria for having a radical in simplest form is that there are no perfect squares under the radical. The second is that there are no radicals in the denominator. It's okay if there's radicals in the numerator, but not in the denominator. So you need a technique to get rid of a radical in the denominator. So if I have this is not in simplest form. The technique to get the radical 3 out of the denominator is to multiply the numerator and the denominator by the radical in the denominator. Okay, I'm looking at this, and my radical in the denominator is the square root of 3. So I'm going to multiply both the numerator and the denominator by the square root of 3. This is going to give me 7 times the square root of 3, and then square root of 3 squared. Something to remember is that a radical multiplied by itself is equal to the radicand. So if I have, square root of 7 times the square root of 7, which is the square root of 7 squared, this equals the radicand. So two radicals, or a radical multiplied by itself, equals the radicand of that original radical. So here I end up with 7, the square root of 3, and following this property, I know that I actually get 3. Now this is in simplest form because I no longer have a radical in the denominator. I have one in the numerator, that's fine, but I don't have one in the denominator. Okay. Sometimes the radical in the denominator will actually be part of a binomial. So in order to eliminate a binomial that's in the denominator, you need to multiply the binomial by its conjugate. And conjugate means a binomial with the same terms but the opposite sign. For example, just forgetting the radicals for a second, just to be really simple, here's a pair of conjugates, a plus b and a minus b. So just very simple, same terms, but this is the sum, and the conjugate of that is the difference. And the other way around, the conjugate of a minus b is the sum, a plus b. So now looking up here with the radicals, p radical q plus r radical s is p square root of q minus r the square root of s. So same term here, 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 and here, just different signs. Okay, so in order to get that radical out of the denominator, if you're dealing with a binomial, you need to multiply by the conjugate of the binomial. For example, if I have 5 divided by x, radical x, plus 3 radical y, for example, I would eliminate this radical from the denominator by multiplying by the conjugate, by multiplying both the numerator and the denominator by the conjugate. So I know that if I have the square root of x plus 3 square root of y, the conjugate is going to be the square root of x minus 3 square root of y. And I'm going to multiply the top by the same thing. And I'm allowed to do this because I'm just multiplying by 1. And that's the same holds for what we just discussed. The way you can get rid of these expressions, radical expressions in the denominator, is multiplying the top and the bottom by the same thing, so you're essentially multiplying by 1. Okay. Now, we've talked about a few techniques for getting a radical into simplest form, but how do you know when it's finally in simplest form? There are 3 criteria to look at. The first one is that when a radical is in simplest form, no radicals will have perfect squares other than 1. So again, going back to what we used in the beginning, square root of 5x. This does not contain any factors that are perfect squares other than 1. Second on my list, there are no radicals that contain fractions. This meets that criteria. Finally, there are no radicals are in the denominator of a fraction. So this does not have any radicals in the denominator. So whenever you're trying to simplify a radical expression, at the end, double check and make sure that it meets all 3 criteria.